Hello students, in this video we will start with the fifth chapter in Science 1, that is heat. Now what is heat? So heat is the transfer of kinetic energy from one medium or object to another, or you can also say that it is the transfer of energy from an source to a medium or the object. Now you may say that what is temperature then? So temperature is the degree of hotness or coldness of an object. And to measure heat, you can find out the temperature and we can know that the heat is there. That is, if it is high temperature, the heat, more amount of heat is there. Now we have already learned the different effects of heat. It changes the state of matter, it changes the temperature of an object, it changes the solubility of a substance, it changes the size of the object, it changes the color of the body, it changes the volume of the body as well. And if you don't remember, so the SI unit of heat is joule. We have also learned that the heat energy that is transferred, it can occur in three ways. That is through radiation, through conduction and through convection. So now what will be conduction? So conduction is the transfer of energy in the form of heat or electricity from one atom to another within an object by direct contact. Then what will be convection? Convection is a type of heat transfer that can only happen in liquids and gases because it involves those liquids or gases which are physically moving. So here in this picture, the liquid, that is water, that is getting heated. So that is called as the convection. Then next is radiation. Radiation is the direct transmission of heat, or you can say the electromagnetic energy through space or any other medium is called as the radiation. Now here the radiation is through this coil which is there in the gas, and then because of that radiation, conduction, convection occurs. So this is the different ways or in which the heat transfer takes place. Now this year we will be studying some new concepts of heat, out of which the first one is the latent heat. So what is latent heat? Latent heat is the heat energy per mass unit which is required for a phase change to occur. Let us understand this through an experiment. So what we are doing is that we are taking few pieces of ice in a beaker, and then we will insert a thermometer in the ice and we will measure the temperature. Now we will put that beaker to heat, that is through burner, and we will record the temperature using the thermometer after every minute. So after every minute you have to see what type of changes is occurring because of the heat. And as the ice is heated, when it starts to melt, we need to stir it continuously and we need to keep recording our temperature. And after recording the temperature, you have to plot a graph of temperature versus time. That in one minute, what was the temperature that was there. So for that, we need to plot a graph for this. So after we start to heat the beaker, what we observe is that the temperature is 0 degrees Celsius till the ice melts in the beaker. So till the time all the ice which is there in the beaker it melts, the temperature is 0 degrees Celsius. But after this time, if we keep on heating that beaker, then the temperature which is there, it starts to rise, and after some time it will reach 100 degrees Celsius. And at this temperature, it starts to convert the water into steam. We all know that after 100 degrees Celsius, the water starts to convert into steam. So the temperature of water remains constant at 100 degrees Celsius till all the water gets converted into steam. And now when we plot the graph, so on the graph, the line AB which is there, that represents the conversion of ice into water, and this was constant. That was, it was 0 degrees Celsius only. Then the ice absorbs heat, that is, as all the ice has melted, it will start to absorb some amount of heat because we are continuously giving it heat. So because of the absorption of heat, the energy which is there in the ice, it converts into water. Now we all know that the temperature at which the ice converts into water is called the melting point of ice. So thus what will happen is that the transition takes place, that is for some time the atoms which are there, that is the water atoms which are attached together, that is in the solid form. So the heat energy is utilized for weakening the bonds between the atoms or molecules in the solid and transform them into liquid phase. So this heat energy which is absorbed at the constant temperature, because for some time it will remain constant from A to B, it will remain constant for some particular time. So that time the heat which is absorbed to break those bonds, that is called as the latent heat of the fusion. So we can define latent heat as the amount of heat energy which is absorbed at constant temperature by unit mass of a solid to convert it into liquid phase is called the specific latent heat of fusion. So now at point B, when all the ice which is there, that is which was in solid form, gets converted into liquid form, and then after that the heat is being absorbed by the water and the temperature starts to rise. Now the temperature will start to rise from 0 degrees Celsius. Slowly it will gain all the heat which is there and it will become 100 degrees Celsius. So from 0 degrees Celsius it rises to 100 degrees Celsius, and here in the graph, that is point BC, is the denotion that the temperature is rising. Now at some point, that is at 100 degrees Celsius, now the temperature will be constant, as the temperature cannot increase more. In the last temperature, that is 100 degrees Celsius only, and after 100 degrees Celsius the water starts to convert itself into the form of vapor. So this point, that is at the point at which the water starts to convert itself into vapor, that is called as the specific latent heat of vaporization. So you can say that the amount of heat energy absorbed at constant temperature by unit mass of a liquid to convert itself into gaseous phase is called the specific latent heat of vaporization. So the point at which the heat, that is the water which was there, it absorbs all the heat and it cannot rise more and starts to convert itself into vapor form. Now we all have enjoyed golas from the golawala. Those are called as the ice balls. But have you observed what they do? They take an ice slab and they shred the ice, and then they pressurize the ice on a stick. So how that shredded ice sticks to that stick? So this is because the shredded ice gets converted into the solid form. So this phenomena is called as regulation. To understand this, we will see an experiment. We will take an ice slab and we will take one string. We are taking two weights and we will tie the weights on both the ends of the string, and we will keep it on the ice slab. So now what we will observe, that because of the pressure what is happening, the string will cut through the ice slab, and you will observe that the ice has not broken. It does not divide into two parts. So why it does not divide? It is because of the phenomena that is called as regulation. So what happens is, the melting point of ice which was there, because of the pressure that was applied, it was melting, and the melting point lowers than the 0 degree Celsius. Now this means that 0 degree Celsius the ice gets to convert into water. But as soon as you remove the pressure, the melting point which was there, it gets restored to 0 degree Celsius. So as the point was getting lowered, but as soon as the pressure is removed, so the melting point which was there, that is the point which it was going down, so it does not go down and it becomes 0 degree Celsius only. So this phenomena is called as the regulation, in which the water gets converted into ice again. Now we all know that when a liquid is heated to a certain temperature, it expands, and when it cools, it contracts. But water does not show, it is an exception. Now what happens is, when you heat water from 0 degrees Celsius to 4 degrees Celsius, it contracts instead of expanding. So at 4 degrees Celsius, its volume is minimum as it is contracting, and if the water is heated more further, so it expands and its volume increases. So this behavior of water, that the behavior between 0 degrees Celsius to 4 degrees Celsius, is called as the anomalous behavior of water. The contracting of water that takes place, that is called as the anomalous behavior of water. To study the anomalous behavior of water, we can use an apparatus that is called as Hope's apparatus. Now this apparatus is designed to show the water has a maximum density at 4 degrees Celsius. So the apparatus, it has a cylindrical container and it has a bowl here, and there are few spaces here where we can attach the thermometer. Now inside the cylindrical container we add water, and in this bowl we add ice and salt, and we attach the thermometers through these provisions which are given in the apparatus. And what we do is, after putting ice and salt and water, after starting the experiment, we start to record the temperature. Now we record two temperatures. First is from the thermometer 1. So from here, with this thermometer we will record the temperature, and second is from this thermometer. So there are two thermometers which are attached. So from these two thermometers we record the temperature, that is T1 and T2 will be the temperature that will be recorded, and this temperature is recorded after every 30 seconds. So when we plot a graph of the temperature and the time, now we have two temperatures, that is T1 and T2. So from the graph you will see that the T2 that is there, it does not fall very fast, but T1 which is there, it starts to decline, that is there is a rapid fall from the start only. So this is because initially the temperature which is there of the water, which is in the middle of the cylinder, it lowers due to the freezing mixture in the outer bowl. Now we have put the freezing mixture in the outer bowl. So because of that, the water which is there inside, it starts to freeze. Now since the temperature of water decreases, its volume also will decrease and the density starts to increase. So the water with higher density moves downwards, and therefore the lower thermometer which is there, now lower thermometer is T1 only. So lower thermometer, that is T1, it shows rapid fall in the temperature, and this continues till the temperature of water becomes equal to 4 degrees Celsius. Now when the temperature of the water starts to decrease below 4 degrees Celsius, so now what will happen is the volume which is there, it will increase and the density will decrease. Ulta it happens. Now because of the volume is increasing and the density is decreasing, so therefore it moves in the upward direction, and the temperature of the water in the upper part, that is T2, therefore it decreases to 0 degrees Celsius, and the temperature of the water in the lower part, that is T1, it remains at 4 degrees Celsius for some time, and then afterwards it will also decrease to 4 degrees Celsius. So from this experiment we can understand the anomalous behavior of water. Now you must have seen in the cold regions that the top layer of any water body, it freezes, but inside the aquatic life it is preserved. So this is because of the anomalous behavior of water only. So as water which is there from 0 degrees Celsius to 4 degrees Celsius, it contracts, and beyond 4 degrees Celsius it expands. So the density of water is high at 4 degrees Celsius. So when the surrounding temperature goes down, the water in the ocean and the river also starts to cool down. And what happens is the water which is there, the temperature of the water reaches 4 degrees Celsius. The whole water, it reaches 4 degrees Celsius. So the water is maximum density, as it has the maximum density, and below this temperature, that is below 4 degrees Celsius, the water layer which is there on the surface, it expands, which is caused by the anomalous behavior of water because of its decrease in density. and as the colder layer which is there, it remains on the top, so it acts as an insulator, and the water which is there below the top layer, it remains the same, and because of which the temperature is also maintained, and whatever life is there inside, that in the aquatic life which is there, that also can be preserved. So by using Hope's apparatus and by plotting a graph, we can easily understand the anomalous behavior of water in the laboratory as well.